Right, guys, can you hear my voice? Am I audible to all of you? I want all of you to just confirm that over the chat once, because I'm really having some issues with my internet today. Is my voice loud and clear to all of you? Guys, is my voice clear? Can you hear me?
Yes, sir.
Oh, all right. So is there any background noises that you are getting from my background?
Not much, sir.
All right. All right, guys. So let's begin from there then. Okay, I'm very sorry that I got held up and the class got delayed. I'll be extending the class by the same. All right. So I want one of you to tell me about what was the topic that we have discussed in the last session. I believe the last session was with Kajal ma'am, right? Guys, can your cameras on now?
Yes.
Make it quick. Just make it quick, everyone. Jasam, Neeraj, be quick, guys. We are already late. All right, Shika. No issues. What about others? Be quick, everyone. Okay. As far as I remember, that Kajal ma'am took your last class. So guys, just walk me through it. What have you learned in the last class? What was the basic point of discussion in there? Gautam, Supriya, I'm waiting for you guys. Rehan, Pratham. Acid, bases, and salts. Some part means were you discussing the problems or something like that? What were you discussing the intent? All right, all right. See, I guess this was already announced to you that what we are going to do today. I already told you that our topic for today's discussion would be the metals and non-metals, that part, right? Now, considering this chapter, we'll be discussing about the questions and the way we were taking the last few classes. We'll be continuing in that way. All right. So today, definitely the metals and non-metals chapter that you have learned before. I have taught you a lot in details in there. And the basic point of metals and non-metals from where you can expect questions is kind of where the metallic activities are being given, right? How the different type of reactions, first of all, like the hydrogen, when it reacts with the acids, how it donates, how it gives out the hydrogen. There are 4 or 5 variation of that. Okay, make sure you know all of those things. All right, I'll be giving you examples what I'm talking about right now. Then again, there are the uses kind of a thing, like how the metals and non-metals are being used in everyday life and what all issues that you're going to face. Like first of all, like the curd thing, how if you keep curd in a copper or a brass vessel, then what would happen? So those kind of a question which is related to the everyday life related questions. Okay. And the third thing that you can expect from metals and non-metals is questions related to its oxides. Okay, so I'll be talking about all these 3 kinds of questions that can come, and definitely, guys, we'll be discussing about that the way we do in the normal classes as
So
well.
also like the extraction of metals, right?
Yes, definitely. The extraction of metals, we talk about that. The processes are pretty straightforward, so I don't think so. You should be struggling with that. But again, yes, that is another portion. Basically, from the extraction of metals, they just put more pressure on that roasting and the calcination portion. All right. So we'll be talking about all those type of questions today. All right. Now, we just share my screen with you real quick. I can clearly see many of you haven't turned your cameras on. Arham, I got your text. You are excused. Farha, Apratham, what is taking so long, guys? Okay. So guys, I hope you know that the JEE results are out, right? Is there anyone who you know that who is giving JEE? Kapital, Neeraj, everybody close to you who have given JEE or something? All right, family friend. Okay. See, a friend of mine, but I haven't asked him yet. But they haven't told the results yet. Yes, Abida, I know about you. All right. So see why am I asking these questions to you? See, as you know that this is something that you will be doing once, isn't it? Not about JEE. I'm talking about any competitive exams right now. Okay, try to get my point. See, you are gonna do something, right? Either you're gonna give SAT, or you're gonna give JEE, or you're gonna give NEET. Let's say you don't want to give anything. You are not into any of these things. But let me tell you, whatever you do in your life, whatever path you choose, you have to give a competitive exam. I want you to be in this culture a little bit. For those who know their friends or someone close, for that, they do understand how the situation is when JEE comes. For example, Abida, you know already, right? How the things becomes, how tense it is out like around you. And guys, one more thing that you can learn in this particular situation, that your performance in this class with me and your performance right there, they're gonna be hell and heaven difference in there. All right. So it's like, let's say you are at your 100% right now, there you would be at your 50%. Now, at your 50%, how can you turn it around? That is what you have to learn from them in here. All right. For those who are giving JEE, they have two opportunities in there. But still, guys, sometimes what happens is, as we are not really like, we have that mentality that we'll be sitting for the competitive exam, although we are practicing for it. But guys, when the time comes, it's not going to be that easy, because see, think about it. You have been practicing for this. You have been waiting for this moment for this past 4 or 5 years, isn't it? You're practicing yourselves. You're making yourselves. Right now, what are you doing? Right now, you are trying to be a little bit ahead of others. Why is that? Definitely, you want to be there whenever there any competitive exams are there. You want to be there, right? So, when the time comes, it's not like a normal Olympiad or something. When you give an Olympiad, you know that I'm going to give another Olympiad later in the next year, and you're not going to lose anything. But here in JEE, it's all about the persistence, and it's all about the way you can keep your head. All right. So guys, always there's a small thing that I would like to tell you. Let's say from askIITians, whatever we teach, you are thinking that okay, there are a lot of things which is extra, lots of things which is advanced level or something. So I don't get them. Let's stick to the basic. Let's stick to the boards level. See, the point is you can stick to the boards level, but the major thing is when the question comes, how you handle it. I'm not really teaching you how to like. I'm not really teaching you things of class 11th and class 12th. All I'm trying to tell you is when the question comes, how you can be precise. And let's say you have forgotten everything. I had a friend who used to forget everything when he used to give any exam. Have you ever faced this sort of thing? Out of pressure or tension, he or she would have used to like forget everything, like from which chapters the question is coming. Like that, used to go like that. And you haven't faced the situation yet. So you can't make any comments so far. When the time comes, these kind of things also happen. I'm not scaring you out right now. All I'm trying to tell you is you have to be prepared for the time when it comes. Even I have a friend like that. Yes, that happens. Now for them, if you really want to help them out, guys, just remember one thing. When you can build a concept right out from the basic, that is when you can never fail in any exam. Fail means I'm not talking about pass or fail. I'm talking about the targets that you're targeting for. You have to come to every concept from the very basic. That is what I want all of you to do when the question, I'm going to talk about the questions. So guys, today when you'd be writing any question, when you'd be saying how to answer these questions, you'd be starting from the basics and make sure that you reach out to the advanced level from there. All right. So let's begin this. So the first question, it's a very simple question for Gautam. So Gautam, think about it. Take 30 seconds. Others also think about this question. You have a 2-marker question right in front of you. How would you answer this question when this question comes in your mind? Take 30 seconds and then you have to say it. All right. In the meantime, Rehan, Jasam, Alan, if your camera's on. Gautam, just say it out loud because everyone needs to hear this, and on the basis of that, they would be improvising this answer. So
Yes, so they should not be kept in copper or brass vessels since they react because there are acids present in curd and sauce substances.
okay,
So those react and produce hydrogen gas, which is which is toxic for the which makes the food item not consum for it. It's unfit for consumption. And then that's it.
okay, that's what you're gonna write. What the question comes in. Okay. Now, guys, you have this answer in front of you. How would you modify it? Abida, you would go first. If there is something to modify. Yeah.
Sir, this toxic salts are produced which are harmful.
Mhm.
And also we can give a raw chemical reaction over there by writing metal plus acid gives salt plus hydrogen.
All right. That's a good point.
That's also
Giving a reaction always gives you an edge over any answer over there. Lead to corrosion of this vessel. All right. We can add the point of corrosion over here.
So we can add that curd contains lactic acid.
Yes. That can join all the dots in there, guys. See, we are writing acid. But if you just write lactic acid, it cannot be more informative. See, every substance has a particular acid. Just write the name of that. So curd has lactic acid. Now it gives out hydrogen. Now it makes sense. Like copper and brass, when it reacts with it, metal plus acid gives you salt and hydrogen. So now it gives out hydrogen. See how the things are related. Like if I read this particular answer, I would learn this question. Right. So curd contains lactic acid. Then you give this reaction, or you give it reaction later. Then it gives you hydrogen gas out of it and the toxic salts. All right. And then the corrosion. Can curd be kept in metal alloys? It completely depends on that whether the reaction is going on or not. If you give particular metals where the reactions are not going on, then you can keep it, no issues with that. But then again, remember, alloys also keep their metallic properties. So you have to be very much cautious about that. So it's better not to keep it any of the substances, like because if over here you can clearly see that this brass over here, it's an alloy, right? So brass is also equally reactive. Okay, in my house we do. There you go, Pratham. Use it in everyday life, whatever you've learned. All right. That's why it should be kept in something like earthen pots or something. If you can keep it there, that's better. Don't keep it in any of the vessels. Okay, so that can be a good answer. Is there anyone who would like to add anything? I don't think so. Anything is needed, isn't it, guys? Adding more things is just gonna extend this question. This is fine. If you like, let's say you have given the entire exam and then you have some time in your hand. So all the things that you can do is right now. What can we add on here, guys?
So we can enter metals readily react with the acids.
Metals.
Some metals readily react with acids.
That's right. But that is something that you'll be writing here, right? It has acids and will be reacting with acids and giving you a product. Any ideas, guys? Can we add anything else in here? It's completely fine if you write this. You are gonna get 2 out of 2.
Yes, sir, you could maybe underline the important points like lactic acid and all. You can underline that.
Don't do that. Underlining is something like if you have excess of time, lot of excess time, then you do that because they are not gonna change anything. Actually, that's what I meant. Okay.
I think we can add that.
Yeah, go on, Dheeraj, go on.
Yes, sir. I think we can add that usually curd and all sour substances are acidic in nature, because in question it is given that curd and sour substances.
Mm-hmm.
So we should also mention about sour also.
Yes. So curd and sour substances, both of them are mentioned. I don't think so. Other than that, anything is needed. Okay. So it would be unnecessary for us. All right. Now, Supriya, you'd be trying the next question. So metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved to extinguish a burning candle. Write the balanced equation for the reaction if one of the compounds formed is calcium chloride. Take your time. 30 seconds is what you got. Just a sec. Yes. Metal compound A is there that is reacting with hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Which gas is that? Write a balanced chemical equation if one of the product is calcium chloride. A metal compound, Gautam. Yes, Arun. Supriya? Turn now.
Yes, sir. So the gas which is produced is hydrogen, carbon dioxide.
Carbon dioxide, okay.
Yeah. And the reaction, right? I'm supposed to say the reaction.
Just the way you're going to write this answer.
Okay, so calcium carbonate reacts with HCl to form calcium chloride and carbon dioxide along with water.
Is that how you're going to write it?
Yes, and then I'm going to give an equation.
Okay.
CaCO3 plus 2HCl gives CaCl2
Okay, CCl2.
plus CO2 plus H2O.
Okay, got it. The equation is there. The statement is there. Now you are saying that this is the gas, right?
Yeah.
Okay, now what's next? Is there anything else?
That's
All right, all right. So CO2 is the gas which is extinguishes the fire.
yeah.
Okay. Fine. And so the 2-marker question, I got a statement and I got the equation. Okay. Now, okay, there are so many modifications waiting. Yes, Arham, you go first.
So for the first one, it places the compound calcium carbonate as a variable. So I think we should answer that first by saying that the metal compound A is calcium carbonate, and then write the equation and the statements.
Okay, so you're just trying to rearrange this thing like a way that metal carbonates that you're talking about the metal compound that is A, which is calcium carbonate, and then you're going to write this, right? That is
Yes.
what you're saying.
So
All right.
also the states.
The states, you're going to add the states. So tell me, what are the states you're going to write?
So for CaCO3, that's solid.
Mhm.
Then HCl, it's aqueous. Then
Aqueous.
yes, sir.
Mhm.
CaCl2, it's aqueous. CO2 is gas, and H2 is liquid.
And what about CCl2? That is also aqueous.
Yes, sir.
Okay, and CO2 is gas.
Gas, and then
And H2 is
liquid, sir.
liquid. All right.
So not that sure about CaCl2 state. I think it's solid or aqueous. I'm not that sure.
Okay, I got it. Yes. Who's
So, and
next?
also like to write the name of the compound like below that.
Which one?
So let's CaCO3. Like,
CaCO3, calcium carbonate.
right? Yep. And like for CO2, we can like put an upwards arrow.
They're all technical things that you're covering right now. Very good. Okay, great. Jason?
So we can also write that metal carbonates or bicarbonates react with acids to give their respective salt, water, and carbon dioxide.
No, when you're saying that metal carbonates, then just write that salt and carbon dioxide. But when you're writing metal bicarbonates, you just add the word respectively, because water is not forming for carbonates. It's only forming for bicarbonates, isn't it? Don't give them any chances over there, guys. All right. So you are gonna write a generalized equation, and then you're gonna come to this, right? Okay, I got it. Let me just check the chats real quick because there are a lot of things in there. Even if that's correct, whatever you have written, the entire equation. Writing physical states are not necessary. Again, see, what I'm saying right now is whatever Subhapriya has said, that is enough. You are gonna get 2 marks. But I'm trying to tell you about when you have some time, how can you make this a little better answer? Because see, our target would be always be to set a bar in the examination hall. Okay, so that is what you have to look forward to. More you can do this, that is when you are the proper competitor. All right, so this is exactly perfect, guys. Always remember, there is one small thing, one very technical, small and technical thing that can give them a chance to cut your marks, which is after you have balanced an equation, don't keep the arrow in there. Very small thing, but still, guys, if somebody wants to cut your marks, they have a logical approach for this. Don't write an arrow after you balance an equation. If you don't balance an equation, keep the arrow in there. All right, Sajidal? We have to always write an equal sign in there. Okay. Now, okay, that's fine. Other than that, nothing else can be added up. I guess you guys are getting this. What all things we need to add during a reaction? Okay. Now let's see, how do you solve this question? Apratham, you got 30 seconds. Think about this. Yeah. Sachitan, you are writing in the wrong account. Okay, that time is over now. Now tell me, guys. Apratham, how would you answer this question?
So first it is asking what will happen if a solution of sodium hydrogen carbonate is heated.
Mhm.
So sir, we can write it will decompose into from sodium bicarbonate, it will decompose into a sodium carbonate, and it will also release we can say carbon dioxide gas, which is evolved with brisk effervescence, and then we can give the equation for it, and H2 also.
Okay. And then you're gonna just balance this
Balance,
equation.
yes, the balance. So that's going to be 2 sodium bicarbonate.
This, right?
Yes.
All
And
things
so
are
we
done.
can write the states also.
You can write the states and then all the things in there, right?
And
Is
above the
anything
arrow, we
proper
can just write
other
the
than
heat
states?
delta.
Okay.
because it says heated.
All right. So this is how we do this. Okay. Guys, I'm not talking about the technical things right now. What all like logical things that we can add in here? Technical things are there. Balancing the equation, saying that the states of the matter, then all those things are there. This is what everyone is, this is what most of the people are gonna write. What all extra things can we add in there?
So we can add the common name. So baking soda.
Yeah, that is what everyone is saying, that we can write the form of baking soda. That got me thinking.
So
If I call it,
so we can also no, sir, sorry, sir. Yes. I was
okay,
thinking about the flame, but I forgot.
no, it's fine. See, first, I would just ask you a simple question. Baking soda is what you're gonna call this, right? But you have seen that there are another topic, there are another compound of them which is known as baking powder. So I do know that you have heard about both of these things, but I would like to hear from you though. So Sachetan, what is the difference between baking soda and baking powder?
Baking soda is NaHCO3, which is sodium bicarbonate, whereas baking powder is NaHCO3 plus acid, usually tartaric acid.
Very good. And why do we do that?
Not sure, sir, but I guess it releases more CO2.
That's why we are keeping it, isn't it? We need the CO2 in order to make the cakes and everything fluffy. So why are we even keeping that acid in there?
So it reacts with the compound and releases more CO2.
No, not really.
May I?
Yes, sir. Go on.
Sir, it like tartaric acid is a sweet and like edible acid, which would have like negligible.
I would just stop you there. I would just stop you there for a second. Tartaric acid, they're in tamarind. If you have ever taken tamarind, I think you should know that that's not sweet. For sure. Isn't it?
Sir, like at some extent it is, right? Like
Okay, I would like to hear you out completely. Go on.
sir, so like tartaric acid is a mildly sweet and edible acid that would like have no like negligible effect on baking soda itself, and would provide flavor to uh, the cooked
Okay.
stuff. And like also baking soda contains some like constituents that is harmful for the body, whereas so like the product formed by adding tartaric acid, which is sodium tartrate, like replaces those harmful products.
Okay, I got it. A little bit of idea I have got from there, and some of you are writing in the chat, and that is, let me just check who was that. Okay, that's a very huge thing that you guys are missing right now in this answer. There's a huge thing which is there. You are thinking about very small things in there actually, but it's not that small. And I would be cutting marks for that. It's that kind of a mistake that is there in this answer. Ashita, that's correct. Ashita, the answer is the answer which is exact reason behind the tartaric acid, but Aham, you are also correct in there. Avinav, that's right as well. Yes.
No, sir, I was going to say it's because it neutralizes the bitter taste.
Yes, that is the exact reason. What happens is sodium bicarbonate is kind of it's giving you that carbon dioxide, but then again, it's making it a little bit bitter in taste. This tartaric acid is actually neutralizing the taste. All right. As a result, we keep the tartaric acid in there. But guys, that's not my question. There is a huge mistake which is there. Not a mistake. I would rather call it's an incomplete answer. Where we can just make the modification to make it a better one. Okay, I got disconnected. But anyways, you have seen the answer, right? Don't you feel that there is something really important missing? What would happen if a solution of sodium bicarbonate is heated? That is the question. Yes, Sachetan, definitely we can add that word. It's a decomposition reaction. That is correct. But you're going for the simple, very minute things right now, where there is a huge thing waiting for you. What is it? Sodium bicarbonate is being heated. Is that the answer you're going to get? Na2CO3 plus CO2 plus H2O?
So is it like writing Na2CO3 with like 10H2O? Like for what?
There is no water in there. We have not started with water as well, so there is no water.
So but
States, not the states. Not the
Na2
states.
so no, sir, like Na2CO3, which is like basic baking soda, like washing soda, has water of crystallization, right?
They're not saying the baking soda right now, right? They're saying that only bicarbonate. Not that. See, they are not really talking about the temperature that is given in there, right? You have to give this reaction all the way till the end. This is halfway, isn't it? If you keep on heating it, the Na2CO3 would break into what? Na2O and CO2. Don't you feel that we need to give that? Because I'm not really saying how much is being heated. If you just keep on heating it, you need to mention this. Otherwise, they can. This is a huge place that where you can keep them from giving them a scope of cutting marks, isn't it, Pradhan? So it would be getting one more step, breaking down into Na2O and CO2. That is where you need to stop this entire answer. Are we getting this, guys? Is that clear? Okay. Now, actually, I just want to talk about this a little bit before I move on to the next question. So let's say there is a particular salt, because this concept is needed for the next question, actually. And you have used this a lot of times whenever you're writing an answer. So let's say I'm writing a salt, which is, let's say, NH4Cl. I don't know whether I've talked about this or not. You tell me. I have written a salt, NH4Cl. What kind of salt is this? Is it acidic salt? Is it basic salt? Is it neutral salt? Acidic. Acidic. Okay. 3 of you have said acidic. Okay. Why do you think that this is an acidic salt? That is what I want to know. Avita, you go first.
Sir, we look at the parent acid and the parent base. So the parent acid is HCl, which is a strong acid, while NH4OH is a weak base. So a strong acid and a weak base will give you a acidic salt.
Okay. That's the right answer. This process that you are following over here, guys, that is correct. I'm not trying to tell you that there is an exception to this, but in class 11, there's a chapter that you're going to learn. In that chapter name is equilibrium. They are going to question this method. This way that you have learned, that is right. But in class 11, there will be a chapter called equilibrium. There, they are going to question this method of yours. Okay, if you're finding in this. So it is correct. It's not wrong. It's called acidic salt just because when you hydrolyze this reaction, when you react it with water, the solution that we get, the pH is less than 7. That is correct. And why is it less than 7? Because of the acid being stronger in there. But actually, guys, the proper reason behind this is something that I taught you once. Do you remember that method that I taught you about the conjugate acid-base concept?
Does the ammonia acts as a conjugate acid, which is strong?
Exactly. That is what we need to think about right here, guys. The exact answer to this question should be like this. Although your answer is correct, I'm not questioning your answer. The method is all not also I'm questioning right. But as you're moving into class 11th right now, you need to know this way as well. All right, because you're going to face this. So if I am teaching you, then I'm fine. I'll be telling you at that moment as well. But if somebody else is teaching you, you should know that this method was there. Yes, that's correct, Pratham. Yes, see. Now this is NH4 plus and Cl minus. That is how you can break it. Now NH4 plus is coming from NH4OH. Okay, guys, listen to this. This is not going in vain. It's really very important. Now it is coming from NH4OH, which is a weak base, isn't it? Right, Ashita, Raman, Rehan? That is a weak base. So if it's a weak base, then the NH4 plus is going to be a conjugate, strong conjugate acid. Right, Vida? It's going to be a strong conjugate acid. On the other hand, if I talk about HCl, HCl is coming from a strong acid. From there, if you get Cl minus, the base which is gonna, the thing which is gonna get formed, that is gonna be a conjugate base, but that's gonna be weak. Now, I would like to hear from you guys if this concept that I am talking about right now, if you are comfortable with this or not, if you have heard about this or not, because in 10B I have taught this concept. If you are from 10B, you should be comfortable with this. But even if you are not comfortable, this is your time. You can ask me right now. Are we comfortable with this concept, everyone? Conjugate acid base concept? Praha? Rehan? Jason? Jason, you are there. So, great. Supriya, you as well, right? Alan? You as well, right? Comfortable? Now, it's a weak conjugate base. Now, actually, when we react both these things with water, Vida, what happens is only the strong counterpart goes for the reaction, which is NH4. It would be going for the reaction. As a result, NH4 plus and water would give you what? NH4OH. Now, how would I get NH4OH? Because water would break as H plus and OH minus. So NH4 plus would take OH minus and we'd get NH4OH. So there'd be H plus left in there. This is the exact reason, because this H plus present in the solution. This is the exact reason why pH goes beyond lower than 7. Are we getting this, guys? When we have, what is pH? pH is the concentration, negative logarithm of H plus concentration. So from where is this H plus concentration increasing? Because of this way. This Cl minus is not gonna go in a reaction with H2 because it's weak, but NH4 plus would. As a result, you'd get excess H plus. That is how you can calculate, like in class 11, they would ask you to calculate the amount by which it would decrease. The pH would go down. Then you need this process. I don't want you to remember this right now, but keep it with your copy. It would come handy. All right, as we are discussing about this, keep it with you. Come to the next concept now. Do we know about all the salts out there, guys? Acidic salts, basic salt, complex salt, double salt. There are 2 more types of salts. Complex salt is there, double salt is there. Okay. Do remember that if you are uncomfortable with any of them, just write it down. Then I will just tell you about that. Okay. This is the question. Alan, you'd be answering. Take 30 seconds to think about this. Yeah, time is over now. Go on.
So I'm not very sure about the second answer, but I know what the answer for the first one is.
Go on.
So for the first one, so he changes. So as a pH of milk, fresh milk reduces, it will start becoming more acidic and convert to curd. So if he adds a small amount of baking soda to acid, so to the milk, it will not become an acid. It will not become curd. So it prevents the milk from turning curd into curd sooner.
Okay. Let's just start with this again. Will. I'll be writing all the points that you would say. Okay. So arrange it and then again one more time. Go on again. After arranging it. Okay.
So can you hear me now?
Yeah, I can hear you. Go on.
So as pH of milk reduces, it starts turning to curd.
Okay. It reduces means it goes to the
It becomes acidic,
7.
sir. Yes, sir.
Acidic.
Becomes less
Okay.
than 7.
Okay.
So-
That is when
so-
it becomes curd. Okay.
Yes, sir.
Then
So by adding baking soda to the milk, it will so it will change it will slow down the process of turning milk to curd because it's an acid based reaction.
what is the acid base reaction over here?
So it is lactic acid plus baking soda.
Okay. So you're saying that as the, let's keep it at point number 3. So lactic acid and baking soda. So you're saying this is a neutralization reaction going on, right?
Yes, sir.
All right. That's how you can slow down the process. Fine. And you are not really sure about the second part, right?
Yes, sir.
All right. Fine. Is there anyone who would like to answer this question? Let me just pick somebody out here. Farha, would you like to answer this question? Okay. I don't think so your mic is working. Just write it down. I'm waiting for it. Okay. Gautam, Aram, just wait for a second while she writes the answer. Rehan, I want you to keep your cameras on. So you as well, guys. I hate to say this over and over again. Okay. Got your answer. Adding it helps the fresh. Yes, that's correct. But you need to explain that. That is already written in there. But how is it happening? That's what you need to explain. Rehan, will you try this?
Yes, sir. Which student should I answer, A or B?
Anyone. You start with it. Like A is already answered. You can start with the B, or you can modify
Sir,
A, whatever you prefer.
sir, for B, why does this milk take a long time to set as a curd? Because when we add baking soda, it like slows down the process of milk turning into curd.
Okay. How is this going down the process?
Sir, because when we add baking soda, the milk becomes neutralized and it slows down the process of lactic acid, slowly changing the milk from its milk state to curd.
Okay, fine. Great. Abhinav, what do
Yes,
you
sir.
think?
Should I? Yeah. Why does it take a long time to set a square?
Okay.
Sir, it's because of the acid that is sorry, yeah, the baking soda that is added to the milk. The baking soda counters the lactic acid that makes milk into curd.
Okay, guys, just tell me one thing. I do understand what you're saying. It's completely right, and it's like it's logical. But the point is it like after it's becoming curd, that is when I'm giving the baking soda?
No,
There's a
sir.
very
When the
small
baking
thing.
soda is added, it is making the pH alkaline, so the
Yes.
acid takes more time to act.
As a result, yes, exactly. As a result, the milk over there is actually alkaline. So the pH is actually greater than 7. Now, when the acid has started forming, it has to lower the pH from there. Earlier, it was keeping it down from pH 7. Now it has to make it down from pH 9 or something. That's why it is taking a longer time, right? In the first question as well, Alan, they're saying why does he shift the pH of the fresh milk from 6 to slightly alkaline? Yes, for the first question, it's right. Whatever Alan is saying over here. For the second question, guys, just consider that the pH is changing first. Then you have to take it down. Now that gives me asking a question to you. Already I have discussed about this in the class. So when you talk about pH, I told you to mention the word temperature. Although they are not mentioning anything regarding temperature over here, but guys, whenever you say pH, we need to associate the word temperature in here, and it is one of the key points of pH. So I would just like to ask you guys that what is the relation between temperature and pH? Like, how is it really dependent? Like, if I change the temperature, what would happen to pH? So, like, let's say right now the pH is 7. Now I have taken the temperature to 50 degrees centigrade. Then what would happen? What would happen to the pH? Would it not be 7? Or what would happen actually there? Abhida, you try to answer this. What would really happen if I change the temperature?
I think if the temperature increases, the pH decreases.
And any particular reason behind this, why that happened?
No idea. I just heard about it.
You just heard about it. All right. Ashita, that's correct. Arham.
So like I forgot like the very deep reason, but yeah, the change in temperature has an effect on the pH as the temperature increases, the pH of the solution decreases as it results to dissociation of more H plus or H3O plus ions than the OH minus ions.
Exactly. See.
Like
yes, sir. Go on.
So you can continue. It was
okay. See, what really happens is when pH is all about the H plus concentration presented, right? So let's say I have some acids in my solution. Okay, that is having some pH. Let's say I have some carboxylic acid. There is a deep down method. There is where we're talking about how the pH is dependent on temperature. In a simpler manner, let's say I have CH3 all right, this is an acid, so it dissociates partially to give you CH3 minus and H plus, right guys? Now let's say what is the pH of the solution. The pH of the solution, let's say, would be on the basis of this particular H plus concentration. So okay, how do we write the pH in mathematical manner?
pH of curd.
No dear, in the mathematical way, how do we write it? What's the mathematical formula of pH?
I'm not sure.
Not sure. Okay, Yasin? Right, that's correct.
What is the negative log of the H plus ions?
But in water, it doesn't change a lot by rising temperature. It does, but it does. Not a lot, but yes. Yeah, you're kind of right.
So we just
a
don't
lot.
get it that much, right?
What?
Like we just don't taste the acidic nature of water like as it like increases in temperature.
Oh, that's the reason. There's a reason behind this. Okay, Arham. I'll be taking your question as well. And guys, have you heard what Arham said? With increasing temperature, the pH goes down, but we still do not, like when it tastes the water, it doesn't taste like an acid. That's the question he's asking. I'm going to come to you with the question as well. Here, what's going to happen is, guys, first focus on this. It's negative logarithm of H plus, Subapriya. Okay, negative log of H plus. Log is a kind of a mathematical function. Okay, you don't need to know what is it, how does it perform and all. There's just the way we write it. Now, what actually happens is, let's say I'm increasing the temperature, then what would happen? This molecule would break more. The H plus concentration would increase more. If the H plus concentration increases, Alan, then what would happen? This value would increase, the H plus concentration would increase. But now you have seen that there's a negative sign in front of that value. So let's say, Subapriya, right now, negative log of 12 is the value I have. Now that 12 value is increasing to 40. Then what would happen? The negative term, when the value is increasing, when there's a negative sign, the exact value is actually decreasing. Isn't it? So that's why the pH goes down. This is the simplest method, but the root cause is very much deeper down. I don't want to teach you about all those things right now. You would learn it in class 11. You have this things in there. But Arham asked me a question. Arham said something like, let's say we talk about water. pH of water is 7, isn't it, guys? pH of water is 7. Now I'm saying when I take it to the 50 degrees centigrade, what happens is it's 25 degrees centigrade. Gautam, you're going to answer this question. When it comes to 50 degrees centigrade, then what happens over there, Shita? The pH, we would find it to be 7 or something. We would find that to be 6 or something. So pH 6 is actually acidic pH. So when we taste this water as 50 degrees centigrade, it should taste like an acid. That's a great question, isn't it? But it doesn't. Yes, Apurva.
Sir, like a counter argument, like we know that the pH only decreases of water because like the hydrogen ion concentration increases, which because the dissociativity of the water dissociates more. So like water, when it dissociates, the more it would dissociate, like yes, it would produce hydrogen ions, but at the same time, the more it dissociates will also produce more OH minus ions also.
Exactly. It's just very hot. We can't taste it. Is it, Abhida? 50 degrees centigrade is not that hot. We can taste even the water which is 80 degrees centigrade. But don't write these kind of things, all right? 50 degrees centigrade water, we drink it. Don't you drink tea?
And even taste water that is 1000 degrees Celsius, but then we will not be able to taste anything.
Only once. Yes,
yes
only once we can taste it, right? Yes, you know, this joke is this joke I have cracked it in the very first day of class 10. Now you have to grow up. Like this is what I said. Like we can drink H2SO4 as well, isn't it? Concentrated H2SO4, but only for once. All right. Anyways, that was nice. Now, what could be happening over here, Arham? See, the pH is going down to 6. That doesn't mean that it is becoming acidic. That means the neutral pH is now 6. See, Subapriya, what actually happens is, the pH scale is of 14, right? 0 to 14, right? When you increase the temperature, the scale becomes 0 to 12. So in 14, the neutral pH was 7, but in here, the neutral pH would be 6. The scale is actually decreased. Now, why is the scale decreased? Because with increasing temperature, the concentration of H plus is not the only thing which is increased. The concentration of OH minus is also increased because water would dissociate into both of the things, H plus and OH minus, isn't it? So not only H plus concentration is increasing over there, OH minus is also increasing. So you won't taste it like a like acid. It won't taste like an acid. It would taste neutral only because it is a neutral. Only the neutral pH now is now safe. So what I'm trying to tell you guys is at 50 degrees centigrade, if you find somebody having pH 7, that's not neutral, that's actually basic. Did you get this? In pH at temperature 50 degrees centigrade, if we get somebody with pH 7, it's actually basic, it's not neutral. So similarly, we can drink H2SO4 as well. Yes, Gautam, we can drink H2SO4. All right. And don't just go to your lab and take a jar of H2SO4 and go like and ask that our teacher told us this. Okay. Don't do that. Okay. All right, guys. Yes.
So by this, can we conclude that whenever we try to dissociate water into like OH and like OH minus and H plus ions, that the water like doesn't completely dissociate as it
exactly
on like changing the temperature, it would dissociate like at a more
very
speedier.
good point. Very good point. Guys, can you see that I'm giving an arrow which looks like this? You know what do I mean by that? This is reversible sign. That means water is not really dissociating completely at any temperature. That's why they say that water is a weak electrolyte. It's a very good point that you have pointed out right now. This same arrow I have given one more time in here while talking about carboxylic acid. You see that? These, whenever you see the reversible arrows, that means, guys, it's a weak base or a weak acid. It's a weak acid. So it gotta get dissociated partially, not fully. Which means that the dissociation would not be full, it would be partial. So by increasing temperature, by changing the reaction medium, you can alter it. That's the point in there. All right. There was one more question I wanted to discuss about. This, guys, make it quick. Who would answer this? Jasam, you go for this one. You have answered one, right?
No, so I haven't answered one yet.
All right. Go on then. That is against over. Try to answer this now, Yasin.
Yes, sir. So the fizzing will occur more vigorously in HCl, hydrochloric acid. This is because HCl undergoes more ionization than acetic acid, making it more reactive. And we can also mention the equations for each one of them.
How will you do that? Yes, April, we are considering the concentrations are same. That's right.
So it'll be Mg plus HCl gives MgCl2 plus H2.
All right.
Plus H2.
And carboxylic acid one?
Yes, sir. So Mg plus CH3COOH gives CH3COO twice Mg plus H2.
Very good. CH3COO twice Mg plus H2.
We can also write the name magnesium acetate, if I'm not
magnesium
wrong.
acetate. That's correct.
And also we can mention that the fizzing occurs due to the production of hydrogen gas.
This is the reason behind fizzing.
Yes.
All right.
And we can balance both the equations.
Okay.
So it'll be 2 HCl in the first one and 2 CH3COH in the second one. Yes, and we can write the states as well. If
Okay, the technical order. Yes, Ashita. The esters are with ending with white. So this is what I got as an answer, please. So that is what Yasim is saying. Like I have HCl, which is getting dissociated, ionized more with respect to carboxylic acid. And like now you have just learned it, right? You can just show it like this. When you do for HCl, just show two more equations in there. For HCl, give it a single arrow. All right, as it breaks completely, H plus and Cl minus. And like I just taught you today, for CH3OH, to show that it is dissociating partially, give it double-sided arrow and go like CH3OO minus and H plus. Then go like it's a weak acid. After just showing this equation, this lifts your paper up by actually like at least twice, 2 times better. Okay. Then you go give these two equations. We can mention their pH as well. That would be too much if you try to mention the pH. I don't even know what's the pH for this type of solutions. Right. So that's not that much needed, you know.
No, sir, I was talking about like HCl and CH3COH, right? We can add those. Like HCl is pH 2, CH3COH is like 4 or something.
Oh, okay. You are talking about the natural pH for them.
Yes,
see,
sir.
actually,
we can say that HCl has lower like that.
No, don't do that. So, see, pH is actually which is not really telling you what is the like strength of an acid or a base. pH is something which completely depends on the concentration of hydrogen. Now, you would say, sir, it depends on the strength. See, if I take 1 molar HCl and if I take 100 molar CCOOH, I might get similar amount of H plus from both of them. In one case, I'm taking 100 molar. In the other case, I'm taking 1 molar. So the pH would be same in that case. Your point is correct, but see, this is no one is really being able to remember all those values of pH. If you give, then that's fine, but again, that's not there in the NCERT. Try to refrain this. All right. Other than that, the point is, I guess, so far by all these classes, you have got this. Like in an answer, what everyone is looking for is try to give equations. That's the first thing. Try to give at least 4 points in a 2-marker question. 4 key points. Okay. Try to mention anyway, like try to give 4 key points. The moment you're giving 4 key points, they have to give you 2 marks. Half marks for each and every key points. Yes, exactly. And that is what I'm talking about as well. Strength and concentration are different. Okay. So give
Sir?
4 key points. Yeah.
So like for like 4 key points, like can we like state like 3 key points and 1 can be the example?
Yes, exactly. Out of 4 key points, 3 key points, 1 can be example, 2 key points, 1 example, 1 equations. Definitely they can be that. Whenever you're writing an equation, if you're not sure about the physical states, don't do that. Don't write it anything. Because not writing is not going to cut your marks. Writing wrong is going to cut your marks. Okay, if you're not sure about the equations, the states, don't write it anymore. All right. In second pre-boards, I scored 91.93%. All right, that's great. Anything beyond 90% is correct. 33rd. All right, Pratham. I need to talk about this. Okay, after the class, just stay with me. Okay, guys, these are the basic things that you have to have. And along with that, if you really want to add something in there, try to do something like some exception type of things. Try to add in there. What are the exceptions in there? Like when you're writing metals plus acid gives you hydrogen, just try to write if the acid is HNO3, it's an oxidizing acid, so it won't happen in that case. Just the small things would change your answer a lot. Because when you're trying to write that metal plus acid gives you hydrogen, acid means all the acids out there. So you can mention that any HNO3 and concentrated H2O. These are not the ones which are going to give you the H2. They would give you H2O instead. That's the basic thing. In the next class, we'll be talking about carbon and its compounds, guys. And there's a lot of things that we can talk about that chapter. Okay. So study that chapter for before you come to the next class. We'll be talking about some good questions in there. All right. Yes, I am trying to take one if we have in that case. All right. That
Yes,
will be it for today, guys. Apratim, you stay with me. I'll be talking to you. Abida, you as well. Stay with me. I'll be talking to you. Others can leave.
Thank you, sir.
Bye, guys.
thank you,
Good
sir.
night. Just a second. It's the host. Okay. Just 1 second, guys. Just struggling to